Let's take a math problem. Suppose I had a number like 1,270,000. And I was going to multiply it by 0.083. This is kind of awkward to do by hand. I could calculate it all out by hand. I could punch it into a calculator like that. But if I was going to do it with exponential notation, turns out I could do it. I could save myself some work. 1,270,000 is equal to 1.27 million. So I could rewrite this number in exponential notation. Here's how I would do it. 1.27, and then I'm going to write times 10 to the something. And what am I going to write? Well, what I'm going to write depends on how many decimal places I move the decimal point over. In this case, I had a decimal point that started here, and I moved it 1, 2, 3, 4, 5, 6. Moved it 6 places over there. So I'm going to write 10 to the 6. I can verify that 1.27 times 10 to the 6 is equal to this number. Let me just check and make sure I know how to do that. 1.27 times 10 to the 6 equals 10 to the 6, I said, was 1 with 6 zeros. So that's 1.27 times 1, 1 million. You can punch that into a calculator or do it out by hand and find that it is equal indeed to 1.270000. Okay, so now I verify, this is just a check, I verified that this number here is the same thing as that one there. Now if I've got a really small number, what I'm going to end up with is a negative exponent. So here what I'd like to do is move the decimal point the opposite way, 2 places. I'm going to move the decimal point over 2 places. That'll be 8.3. It's an easier number to deal with. And then I'm going to have my exponent part, so I'm going to multiply by 10, and I move the decimal point at 2 places over, so I'm going to write minus 2 because I'm moving it the other way around. I can check and make sure that this number is indeed the same as that. 8.3 times 10 to the minus 2. 10 to the minus 2, I said before, is 1, and I move the 0 2 places over. So there's my decimal point. 8.3 times 0.01, you can verify for yourself that that's the same thing as 0.083. So we've checked to make sure that this number here means the same thing as that number there. Now I can do the math problem. 1.27 times 8.3 is equal to 10.5. I'm also going to have to multiply this by these two exponents, 10 to the 6 times 10 to the 2, 10 to the minus 2. How am I going to do that? 6 times 10 to the minus 2. Well, I could write out 1 million, which is 10 to the 6, times 10 to the minus 2, which is 0.01. I take a 1 and move the decimal point 2 places over to get 10 to the minus 2, or take a 1 and move the decimal point over 6 to get 1 million. I could calculate that out, and I would find that I get 4 zeros. 10,000. That happens to be equal to, let's see, 10 to the 4. 10 times 10 times 10 times 10. Again, this is a 1 with 4 zeros. That must be the same thing as 10 to the 4. So I could say that my answer is equal to 10.5 times 10 to the 4. Now there's an easier way I could have done that. I could skip some of the hassle by noticing that this 6 and this is a minus 2. And if I add 6 and minus 2 up, I get 4. 6 minus 2 is 4. We can write that as a general rule that applies to all kinds of different problems. And it goes like this. 10 to the a, where a could be any integer, times 10 to the b, where b is any integer, equals 10 to the a plus b. Let me give you another example. Suppose I had 10 to the minus 4 times 10 to the 27. How would I do that? Well, a is minus 4, b is 27. So that means my answer would be 10 to the minus 4 plus 27. What's minus 4 plus 27? 23. That's pretty neat. I can multiply 10 to the minus 4 times 10 to the 27, find that it's 10 to the 23 without writing all those crazy zeros all over the place. That saves me a lot of hassle and makes it much easier to deal with very large numbers, and very small numbers too. Let me give you another rule about exponential notation. Suppose I was going to divide two exponents. So suppose I took the number 10 to the 6, and I was going to divide it by 10 to the 2. Well, I could write it out. 1,000,000 over 100. It's 10 to the 2 is with 2 zeros. 1,000,000 is with 6 zeros. And you probably know enough math to be able to do this by yourself. You would get, again, 10,000. 10,000 is a 1 with 4 zeros after it, so I can also write it as 10 to the 4. But let's look at this. 6 and 2 here, and there's a 4. Is there a rule here? Well, it turns out there is. The 6, if I take 6 minus 2, I get 4. So here's the general rule for division. Let's use different letters this time. 10 to the c. C can be any integer you like, over 10 to the d, or d can be any integer you like, equals 10 to the c minus d. So if you're dividing, you better subtract the exponents. So let me do one more example to show you what I mean. Suppose I had 10 to the 34 over 10 to the minus 16. Those are both ugly numbers that would be very awkward to write out by hand. But it's really easy to do that division problem if I use this rule here. C would be 34, so I'm going to write 10 to the C is 34 here. D here is minus 16, so I'm going to put that here. Minus, D is minus 16, so minus a minus number is the same thing as 10 to the 34 plus 16. That would be equal to 10 to the 50. 34 plus 16 is 50. So 10 to the 34 over 10 to the 16 equals 10 to the 50. So you can easily do calculations with very large and very small numbers, division and multiplication, by doing this, by using this exponential notation. Now let me throw in some more complicated numbers.